Good morning once again. There are some, yes, everything is on record. There are some very interesting points on the sideline, but I'll have to take them next time. I'll have to leave you 5 to 10 minutes before 11 because you have your next session waiting for you. So let's look at why is software architecture important. There are many things I've pointed out to you in session 1, but let's go through them quickly. Understand one thing very clearly. Architecture is about quality. It is not about functionality. Object-oriented analysis and design does address quality to an extent, but mainly about functionality. But software architect enables quality. Quality has to be taken care of by dividing a software system into blocks, separate components, so as to render the quality attributes as well as possible. Now, any changes that you may like to make in the system is referred to as changeability, modifiability. So, if you want to address modifiability and that is important for your system, you have to spend on it, and the architect has to design for modifiability. It involves more resources, it involves more cost, it involves more money. So, architect very much has to do with money. Definitely, the architect is an important determinant of how much it will cost to build up the software system. So, since cost is so important, the very last lecture in the course is cost-based trade-off method. We will study that right at the end after we've understood all the aspects of software architecture, and we will look at how the architect does a trade-off on costs. So, an architect gives you the quality features of the system before the system is developed. He gives it to you based on the requirements given to him by stakeholders. He listens, he doesn't hear. He listens to stakeholders very carefully. Then he speaks clearly to the stakeholders and makes it very clear to them that, well, you can't butter the bread on both sides. So he tells the stakeholders about the trade-offs, that if you have a lot of security, it will take you 1 hour to enter the building because we'll have 10 gates, each lock to be opened with 5 keys, and each of the key with 5 different people. And then if you tell us that it's taking an hour to get into the building, well, it's security. So whatever it is, it's got a cost, it's got a trade-off. So you cannot have very high performance if you go in for a very high security. So these playoff is there between quality attributes. Then architect has to document. Under Agile, there is a particular view on documentation, but besides all that, documentation is required because architecture has got to be communicated to the stakeholders, to the development team, to new joinees, so that they know what the software is about. The software architect has to enable early design decisions which are going to determine the cost, the time, and the quality attributes of the system. Like how much time is going to develop, what are we going to deliver? Because take a small financial accounting system, you can develop it in Excel, time taken 15 minutes. You can develop it in Excel, time taken 2 days. You can develop it in C#, having the database in XML in 1 week. You can have an RDBMS with a client server configuration, 6 months project. And you can have an elaborate service-oriented architecture with separated functionalities, and the development itself may go into 3 years and then make it available as a product. So these, which one are you going to develop has got to be decided right in the beginning. They are serious decisions and they are early decisions. So the constraints, the client tells you, you can use any RDBMS you like as long as it is Oracle. How do you do that? So, well, that's a constraint. You've been told to use Oracle. Not to say Oracle is bad, but that's a constraint. Then the organization structure, the actual structure of the organization. Sometimes you say the organization structure re-engineering. Sometimes architects get involved in such a big way in the client organization that sometimes the entire organization structure of the company may undergo a change based on the type of software system you're building. So experienced architects could sometimes be working very closely with management consultants, with HR people to develop a structure which is suitable for running of a particular type of a system. Architects look for systems which are reusable. They try to look for components that are reusable. Architects do work in an environment. They are influenced by the environment. They influence the environment, and we'll get more into that in the next class. Now, an architect is also responsible to make sure that the design does not become too complicated. He simplifies the design. He will, depending on the type of resources you put in, and you are writing a system which is modifiable. The modifiable what? During design, during implementation, or modifiable by changing code, or modifiable at runtime. So all these decisions have to be taken and clearly explained to stakeholders and understood from the stakeholders. The stakeholders should understand very clearly what you have understood as the requirement as an architect. And a good architecture, if it is documented, even new joinees on the project, they'll go through the architecture and know where they stand in the project. I have mentioned a lot, and some of the quality attributes are mentioned here and clearly defined, and I've been mentioning them again and again and again in the last 1 hour. We've talked about performance, modifiability, security, scalability, reusability, there's testability, there's usability, there's availability, to mention a few. So these are some of the important things, and I'm saying it again and again to have impact on you, because sometimes we go halfway through the course and I ask somebody what is the most important requirement that an architect has to address, and the person tells me functionality of the system. No. Functionality of the system is to be achieved, but that is not what architecture is about. Architecture is about quality. So, how to deliver quality in the functionality is the role of the architect. Functionality will get executed by the designers. They will definitely make sure that whatever functionality is required is executed. But you get the functionality with the desired availability, you get it with the desired modifiability, testability, performance, scalability. That is the role of the architect. So he decides how to distribute the system into components, whether to use layers, whether to use client server, whether to use peer-to-peer, whether to use a blackboard, whether to use pipes and filters, whether to use a broker. So these are decisions which are taken by the architect to be able to enable quality attributes. I repeat it again, quality, quality, quality. Now, the architect has got to understand what type of changes are going to be required in the system. To what extent changes are going to be there. Which are the aspects which are not likely to change. And he'll definitely give us prescription of the structures based on the type of changes that are required. You can have local changes, non-local changes, architectural changes. Architectural changes are changes because of which the architecture itself may have to change. You may have to revamp the entire system, and trying to take care of such changes would be the most difficult job. That maybe you jumpstart, you go in for an architecture which is not required now, which may be required after a few years, only because what you are using currently is just transited. So you're going to start a system which is going to be used only within your office, but within 5 years is good got to scale internationally. So you've got to keep that in mind. The architect should be aware of it right from now. Otherwise, the moment you want to go international, you might have to simply chunk your complete system and go for development all over again. So these are things to be understood. Now, there are times when the architect has to go about educating stakeholders. There are situations where stakeholders may not be aware of the quality attribute requirements. They may not understand their importance. And often, software systems developed with good intentions go into the racks and cannot be implemented because people had not envisaged certain quality requirements. An architect, that is why an architect is normally expected to have good domain knowledge. Is supposed to have worked on similar systems in the past. If not, youngsters like you, some of you may be youngsters, some of you may be extremely experienced architects yourself who are just validating their qualifications today. But those of you who are young and just starting off as architects, well, you study your books very well, you'll study a lot of case studies, you will look up applications developed by the company where you work, and you will substitute years of experience by a little bit of good learning. And that's why what training is all about, so that you don't have to go through the same cycle and experience for donkey's years before you can start delivering. So, what I've been emphasizing is that a software architect must connect with the stakeholders. And even later in this course, we will be seeing how you'll be doing workshop with stakeholders. You'll have to understand each stakeholder. You have to understand to begin with who are the stakeholders. The customer is a stakeholder. If you're having an examination system, the people appearing for the exam are stakeholders. The users of the system, the people who are administrating the modules, who are setting papers are stakeholders. The project manager who's going to get the software developed is the stakeholder. He will probably have a few things to say to you as an architect. Coders, testers, they're stakeholders. So people who are maintaining the system are stakeholders. So everybody gives their input, and we have to prioritize the input, see the budget at hand, and take a decision as to how to go about it. Now, an architect has got to be a good negotiator. He has to go in for give and take. He'll give some quality attributes, take some. He's got to make sure that some stakeholders who are strong in lobbying do not road features into the system which are not desirable for the company. He's got to understand the business requirements of the company and very clearly understand why the software system is coming up in the first place, why the company is spending money on it. So the support team, the maintenance team, they are all stakeholders. But when they come up with the feature requirements, the architect has to handle all of them and handle it. And we'll be discussing in future classes as to how the architect goes about it. Now, software architecture is about early design decisions. Say you're thinking of making a building which will be used for a hospital. And then after you build up the structure, you decided not to make a hospital, but make hotel rooms instead. Can you think of it? What are you going to do with the wards with pillars in between? Is that going to be a ballroom? Can the operation theatre be used as a restaurant? Can the rooms which are designed for hospital rooms be used as suites? Will there be enough place? Will the washrooms designed for hospital, the space provided do for a thing? Okay. You design something for a hotel and now you want to use it as residential apartments. Now what do you do? Will it work? So these are early design decisions. You have to decide what that infrastructure is coming out. It's easy to see in the case of a hospital or in the case of a school or in the case of a hotel or residential blocks. In software, some people may not realize how does it make a difference. You were designing a software for a cloth retail, and you say, okay, why not use it for a gold retail? No, those of you who have worked either for cloth or for retail, better still for both, will realize that there are a lot of consideration differences. So, early design decisions are taken based on what you will be doing. Now, what type of design decision? Will two systems be running synchronously or asynchronously? Asynchronously gives you better performance, but on a real-time system, you cannot wait for synchronous operations. You needed asynchronous because you want immediate results. You wait for the result. So, are you writing a system to handle a flight? If you are handling a flight, can you afford to have layers? What is the performance punishment that you will be? I think there are some people who joined the class late and they are asking questions. I will recommend that you go through the recording of the first lecture. So, whether you will be having encryption or not, encryption has a performance cost. The textbook is given to the course handout, and we showed the course handout sometime back in the previous lecture. What are the type of protocols? Which is the desired protocol for communication? So these type of things will be taken care of by the architect. Then I've mentioned even in the previous session that there are sometimes constraints placed upon the architect. You're told that, see, we want this, but this is the budget. Okay, if that is the budget and you cannot develop as per the budget, you probably have to come back and tell the client that, see, this is the requirement, this is the budget, this is what's going to cost to achieve this. If you knock out these requirements, we can bring it within the budget. Is it acceptable? You might have to give alternate plans that you either use this quality requirement or this and this. The client may say quality is not important to me because this software is run on a machine which we keep under lock and key in one room and it's not connected to the network. So the entire cost on trying to achieve quality gets knocked out. Quality attribute security gets knocked out, and it automatically gives you better performance trade-off. So these type of constraints have to be negotiated with the client. Now, when you do a work breakdown structure, the organization structure of the development organization may be involved. So an architect has to keep in mind the organizational structure of the development organization. Also, he has to keep in track the organization structure of the client organization. The client has got a maintenance team. The client has got operations in various locations. Okay, folks, I'll just show you the next few slides, but keep it for the next thing. I think I have to leave this class here. I will continue from where I left next week. Thank you very much, and we look forward to meeting you next week again.